Hello, everyone. Thanks for joining. Today, we have an exciting, relevant topic for you. It's going to be about incorporating geospatial data in cloud-native applications. I know you all are out there trying to do that, and if you are, you're in the right place today. Location intelligence has been described as both a common request and a compelling opportunity for developers to explore. And that's because more and more users seek to understand answers in the context of location. Maps have proliferated as the user interface component in applications. They're a fundamental tool now. Almost could be argued that maps are a universal common language for location intelligence. We're all very familiar with Yelp, and now if you go to many applications, there's map views to help users answer the most simple to pressing questions. And this is because processing power has improved such that maps, which were once considered too process intensive for small devices or applications, are now mainstream. And let's look at the volume and the variety of data that's exploding through sales transactions, mobile devices, IoT feeds. These all have a spatial component. Location intelligence helps us integrate, understand, and predict against these data feeds to build a better experience and derive new insights to our customers and for our users. For examples, troops maybe that are in theater can use advanced analytics to optimize their fleets by understanding emerging spatial trends in demand and in real time. And then there's the predominant issue of COVID-19 and topics that are relevant today. As these pandemics and issues unfold, authorities are relying on measures that are inherently spatial in nature. The contact tracing, the quarantining, the social distancing all have a spatial component. As a result, a number of governments have invested in geospatial information and systems that are now critical to their COVID-19 responses. The bottom line is the importance of a strong geospatial data infrastructure and an open platform cannot be overstated. So with that, this session is going to be for those developers who have looked around and saw that where location is a consideration and an opportunity. Today, we're going to hear about open geospatial standards. We're going to discuss and demonstrate actually building modern cloud applications with open APIs on Kubernetes, aka our Red Hat's OpenShift. And we're going to do it efficiently as we utilize a powerful cloud-native GIS platform. And with that said, I'd like to introduce our panelists today that will be accompanying me. I have George Percivall from Open Geospatial Consortium. George serves as the Chief Technology Officer and Chief Engineer of the Open Geospatial Consortium. As CTO, he's responsible for technology strategy based on OGC member activities and interests and based on OGC technology forecasting. He, as the chief engineer, he chairs the OGC architecture board and promotes consistent and sound architectures, including an emphasis on information projects for NASA and standards development in OGC and ISO. Systems engineering for General Motors, and he began his career at Hughes Aircraft on weather satellites. George holds a BS in engineering physics and MS in electrical engineering from the University of Illinois, Urbana. Thank you, George, and welcome.
Thank you, Michelle. What a compelling introduction. I always appreciate hearing the value of location data, and you provided a very good introduction to that.
Thank you. It is important. That's why we're going to hurry up and jump into this. But first, let me introduce Adam Timm. Adam Timm is from Crunchy Data. As we all know, Crunchy Data is the leader in providing open source software and support for Postgres and PostGIS. George actually spawned an interesting title called geoevangelist. Might dig into that a little bit during the session, but I take it a geoevangelist has a background like his that has probably spent 16 plus years following the data between the Air Force and ground systems and ISR systems and data, otherwise known as drones. I've been around collector of data for some time. Worked with the Geospatial Intelligence Agency, and now he is residing at Crunchy. Thank you very much, Adam, for joining.
Thanks, Michelle. I appreciate the introduction and looking forward to the conversation today.
Absolutely. Well, let's start with you, George. What is OGC and what does it do to improve access to geospatial data?
Yes, compelling question as well. So allow me to give a little bit of introduction about what OGC is. I'll talk a little bit about the standards and how they're applied in a cloud native application, and in particular our APIs that are really moving out quite rapidly now. And in particular, that'll set up a good background for what Adam will show about one of the really key implementations of OGC APIs on one of the key databases for geospatial information. So first, let me tell you what is OGC. So that's the next slide. And we are a consortium, a global consortium, about 500 organizations around the globe, 500 plus. And what we worry about is the community sharing of knowledge about geospatial information, location information, thought leadership, and innovation about that. We are a standards organization, so you'll see several of our standards that have been adopted as open consensus standards. You'll also see our methods for involving broad communities with respect to the development of those standards and their implementations. So let me give you a baseline on the next slide, which gives you a sense of the existing deployed infrastructure based upon OGC standards. These are standards from OGC from about 15 years ago called the OGC Web Services. So these were developed as the first generation, if you will, of open standards for geospatial interoperability and web map service, web map tile service, web feature service, web coverage service. These are deployed operationally for millions of geospatial data sets on about 200,000 servers with all their instances behind them to provide the operational backbone for a long tail of geospatial data that's both publicly accessible and operational in a lot of enterprise environments as well. So it's a wonderful baseline. The reward for this success is to make it better, right? So this was 15 years ago. The web design practices, the technology software development practices have moved on and represent a new way of doing business. And part of that is cloud computing. So let's talk about cloud computing and then APIs. So the next slide gives you a sense of what you're probably very familiar with respect to kind of the basic actors involved in a cloud computing infrastructure. An app developer develops some process, containerizes that, and deploys that into a cloud-hosted exploitation platform, is a phrase you'll see pop up here. Allowing for scalability in the cloud, allowing for all the big data virtues that Michelle was mentioning earlier. Along comes a consumer, an application consumer, discovers that data and application and does wonderful things with it for those societal benefits associated with location data. If we now think about where open standards fit into that, on the next slide you see interfaces that are key points of definition points, interface definition points for allowing the definition of APIs to control this using open standards. So next slide shows those interfaces. And so, for example, deploying the containers, you need some metadata that allows it to be discoverable, APIs for them to be deployed into the cloud, APIs for usability, APIs for discoverability. So that has been the OGC's focus in the innovation program with respect to defining interfaces. So what does it look like? put some terms on that in the next page. The cloud computing deployments associated with OGC. We have developed practices for how to deploy with containers, including things like OpenShift and Kubernetes in the cloud. We use common workflow language for workflow. And then once it's in the cloud, to have those APIs that allow for access to the deployed services. Data manifests, we've been using Stack, and the OGC APIs, which Stack is part of that, as well as the processes and features. And I'll get into the APIs in a little bit more. In fact, it's the next slide, which is our emphasis on OGC APIs. So to look at modern ways of doing spatial data on the web, teamed up with W3C, developed some best practices. We make use of OpenAPI, focus on the developer experience and usability for the development of the standards. Define it in a modular building block way so that you might use all of a given OGC API, or you might use some piece of it in your bespoke enterprise API. The advantage being code reuse, knowledge of the APIs. And so all of this is available in a set of APIs on the next slide, which for spatial folks will look familiar. And maybe for some folks that are new, these are some terms that you really want to get to know about geospatial data features. You're going to hear Adam talk a lot about features. This is the vector kind of data where you've got geometries, roads, bridges, those kinds of things. Coverage data, which includes grids, imageries, what have you. And we have a variety of other things, trajectories as sampling geometries, processes as jobs, metadata, routes, tiles, both vector and raster, and then, of course, maps, cartographic display of that data. You see some upcoming activities with respect to the sprints. I invite anyone who's a developer in geospatial to come check out the sprints and get involved. Don't have to be a member to be involved in those sprints. So let me finish off with the last slide, and that'll build pretty quick. This gives you the structure of the API that Adam will show, which is API for features. Go ahead and show us the part that's generic across all APIs by advancing. And you'll see the landing page and the portions of the API that give kind of metadata about the API. So that's common to all OGC APIs. Second, we see the description of features in a collection. So you can find out what feature collections are there, what names are they, what metadata. And then the last set, advanced once again, we'll see the actual access to the individual features. And so this is the interface and the API that makes this so accessible and usable. So last, I invite you to check out OGC APIs, ogcapi.org.ogc.org. Come get involved and make use of them as you might. Give us your feedback. And that's what I have. Michelle, last slide, just kind of gives some statistics about OGC. But hopefully that sets up a discussion of an exciting demo.
Mm-hmm. Well, first of all, it's impressive that there's 500 plus international members in OGC. Indeed.
A third of them are government agencies, a third are commercial organizations, a third are research and academic, a third in North America, a third in Europe, and a third around the globe. So very healthy community associated with expertise in geospatial. And of course, our key aspect as well is to reach out beyond that member community to large resources and really try to gather that consensus and best thinking of geospatial around the globe so that we can put those to the application, for example, in what Crunchy has and Red Hat.
Mm-hmm. And before I start asking a few questions, I want to remind everyone that we are live, and if you have questions, please put them on the player page, and we'll get to them and try to answer them. And all questions will be answered here or afterwards. But if you have questions for George or any of the panelists, please put them in the player page. George, so now that you have this vibrant community and there's all this interest, how do you actually see Open Geospatial Consortium building out these APIs and having are you providing key implementations that demonstrate these specs or that they work? How are you validating?
Yeah, absolutely. So there's several key elements associated with open standards. People think of the spec, the document, and the like. That is a key part of it. But the implementations that are written in advance and then become the compliant implementations based upon that spec being adopted are another key pillar in the development of open standards. Having those implementations, having the spec without the implementations is not of much value. And data, hosting data so that you can test a range of use cases against a range of different types of data. It's all got location, but there's a high variability of, what types of features are there, gridded data, how do you deal with gridded data? How do you deal with trajectories, flying through a set of data and retrieving that to support various use cases. So having the data, having the implementations, having the specification, and having a vibrant community that comes together in activities like our sprints that I mentioned, like in our standards working groups where the members get together to finalize and vet and vote on that. And it really is an open consensus process. Anybody can be involved, anybody can affect it, anybody can write a issue and have that taken up by the open consensus process. So it's a challenge, but we've done it, 25 years now, and you saw the implementation of OGC Web Services. We see a similar kind of beginning ramp for the APIs, and this discussion is a key part of that to show us the next generation of access to geospatial data using these APIs.
Okay, and as we speak about next generation, Adam, who's going to come up in a second, is going to talk about putting geospatial information in cloud native applications using Crunchy's implementations of some of the open APIs. What is next? What are you tackling next for geospatial data? We got the cloud, we got the edge. What are you tackling? You got the edge. What are some of the new initiatives that you're working on?
Yeah, one of the key roles that in particular as a CTO I lead is the OGC technology forecasting activity and the trends activity, identifying where we need to be moving forward in this role of standards and innovation. And so the open APIs are a big part of that. But other key parts are working with spatial data on the web. So the most general audiences you can get with respect to spatial data, and as you mentioned, Yelp and others, location-based services that kind of go beyond the professional GIS person into the use of that data for a variety of things. We see the space and time trajectories enabled by mobile and other abilities is really a key growth area as well. The ability to get information about a trajectory and make predictions on that for whether it's an airplane or a person or animals, a very powerful, the power of location through space and time.
Very good. Well, you stay around because we're going to come back to you, but we're now going to take what you've done, the APIs and the specs that you've built, and we're going to go to an implementation side of the house, and we're going to bring on Adam, and we're going to see how Crunchy took a different approach to how they implement geospatial information. So, Adam, please tell us how did you all take a different approach to a traditional GIS architecture? What makes Crunchy different?
Yeah, thanks, Michelle. First off, I'll go a little bit into who Crunchy Data is and kind of our background. So first and foremost, Crunchy Data provides secure, trusted support for enterprise Postgres and PostGIS implementations. We are first and foremost a database company, right? So it may seem a little odd that a database company decided to wade into the GIS world, but it really isn't too strange. We had our start back in the DoD and Intel community. A DoD customer reached out to us, and they were looking for help implementing Postgres in a safe, secure, scalable fashion on secure networks to handle trusted mission workloads. So they engaged with Crunchy, and that's really where we got our start. Obviously, we place a key emphasis on security, scalability, and reliability of Postgres and its spatial extension PostGIS, and that's really going to come into play in the demo here in a little bit. I'll be able to show that a little bit. We provide world-class Postgres expertise. We employ core developers, committers, major contributors. We're responsible for a number of open source enhancements around Postgres. You can see a few of them on your screen there. And our support team is staffed by 100% skilled Postgres engineers. When you engage us for support, you're talking with engineers who know Postgres inside and out, not a level 1 or 2 triage help desk, but you are getting connected with actual Postgres engineers that can address your specific Postgres question. Even though we had our start in the DoD, we've expanded out to support commercial organizations as well as other federal entities. And we are a 100% open source company. Therefore, we have no proprietary license fees. We operate on a support subscription model. And because we're open source, we are cloud and platform agnostic. You can deploy our technology anywhere you need to, whether it's AWS, Google Cloud Compute, Azure, your own private cloud, on-prem, your own data center, wherever you need to deploy, you can deploy our technology. And we have a very robust container suite, as well as a Kubernetes operator, which I'll show a little bit of how that works and can simplify your deployment of a database as a service in Kubernetes to support your geospatial applications. So real quick, here's the high-level architecture of what I'm going to be showing today. So it's your standard 3-tier cloud-native architecture. We have a custom UI that's built in React and open layers. We have our microservice layer that consists of PG Feature Serve and PG Tile Serve, which are the 2 new microservices that Crunchy released as part of our Crunchy Spatial product line back in March of 2020. We'll also be consuming base maps from a map server that exists outside of the stack. Just wanted to throw that on the architecture slide for completeness. Our Postgres cluster is going to be deployed by our Crunchy Postgres operator for Kubernetes, and all of this is being deployed in OpenShift 3.11.
Oh, we can't wait.
So before we jump into the demo, I do want to spend a little bit more time on Crunchy Spatial. That really is kind of the core of what we're talking about today, right? Crunchy Spatial is our implementation of one of our services is PG Feature Serve, which is the implementation of OGC API features, the version 1 of that. But we decided to take an opinionated approach to GIS architectures. Crunchy, as I said, Crunchy at its core is a database company supporting open source Postgres, and Postgres has a very powerful spatial extension for it called PostGIS. It's essentially your GIS without a GIS. Now, we designed each service to do one thing and one thing well, but each one of those services leverages the inherent functions and features found in PostGIS and Postgres. Because it's leveraging the inherent capabilities found in PostGIS and Postgres, each one of those services can be incredibly lightweight and incredibly scalable and operate in a completely stateless manner inside a Kubernetes platform. Both of them use the underlying database as the source of truth, so there's very little configuration required of both these services beyond a database connection, and I'll show that as I go through the deployment of each of these. And essentially, this allows developers to leverage geospatial information and development best practices, but do it at scale. They don't have to worry about creating the APIs on their own to leverage the features and functions of Postgres and PostGIS. We've done that for them, and we make it incredibly easy for them to deploy it in their cloud-native platform. But I would also say that you don't need to be deploying this in Kubernetes. These will run just fine in your existing on-prem architecture and kind of more of a traditional server stack as well. So while they were designed with Kubernetes in mind from the start, they do not depend on Kubernetes to run. You can deploy these in conjunction with PostGIS anywhere you've got PostGIS deployed. And with that, now it's time for me to jump into my demo and actually show what I've been telling everybody about.
So let's just make sure we get this straight. You're going to create a cloud native application. You're going to take some source code. You're going to make containers out of it. You're going to use the Crunchy operator. You're going to deploy in OpenShift, the Kubernetes platform. You're going to connect the UI to the back end. You're going to use microservices, and you're going to have a geospatial application up and running.
That's right. Yep.
Let's do it.
All in 30 minutes or less.
Okay.
All right. So here's actually the application we're going to be building. This is a very purpose-built application that we created just to demonstrate some of the capabilities provided by Postgres and the microservices. I won't go too much into the application itself, aside from showing everybody what they can expect in the final application. So what you're seeing here is a map interface, kind of your typical web map interface. We've got a base map being served up with open map tiles, and all of the green and red lines you see are actually parcel data that we pulled down from the Santa Cruz County GIS website. So all of this is real GIS data that we pulled down from a publicly available data source, and we loaded all of the data you see on your screen and even more into a Postgres database that is deployed in OpenShift. And the essential functionality that you're going to be able to see once I'm done building this application is we can select one of these parcels, and we can change one attribute in the database that we've pre-selected, and that's the fire hazard attribute. And when I change that from no to yes, you'll see that the parcel outline changes from green to red. And that's because all of the parcel is being served back as vector tiles through PG tile serve. And the styling is dependent on whether or not the fire hazard attribute field is marked as yes or no. So the UI is determining the style based on the attribute information being provided back as the vector tiles. And the update is actually being done through PG feature serve. We use PG feature serve to make the actual update into the database. And I'll show how we actually do that as I build out the application. The second view that we have in this application is once we've updated the data, it'd be nice to be able to provide a notification to everybody around that parcel that information has changed. So in this view, we can specify a distance of how far out we want to notify folks that the attribute has been updated, that a parcel in their neighborhood is now considered a fire hazard. So we can specify the distance in number of meters. We can do a search, and it's actually doing a geospatial radius search in the database because we have spatial knowledge of all of the information in the database, and it returns back all of the parcel information that intersects in that 10-meter query. We can specify as far out as we want. I just chose a rather small diameter for the demo. So that's the expected functionality that we should see at the end of this demo. So to get started, we are starting in OpenShift, as Michelle, you said. We have a completely blank project space. You can see there's nothing deployed to this currently. There are no applications in here. There's no stateful sets. There's no pods deployed, right? So this is a completely blank project. And we're going to go through and we're going to, the first thing we're going to do, and so now I'm actually going to jump into terminal view because it's a little bit more efficient. So for those of you that don't like looking at command line, my apologies. I will be bouncing back and forth a little bit. So try and make it a little more interesting for you. So first we're going to actually deploy our front end just because our front end is actually probably the more complex piece of software to deploy into open source. And so it takes a little bit longer for OpenShift to actually build that for us. So first I'm going to verify that I'm actually in the correct project space. So I am actually in the project space demo, and just to show once again, everyone, there is nothing deployed. Nothing's there, right? So it came back, nothing's found. So now I can actually deploy my front end by using the OpenShift new app workflow. I'm specifying the GitHub location of our sample code. It's actually my personal repo, and it's, like I said, it's a custom front end that we built just for this demo. And I'm specifying that it should use the source code strategy to build. So we'll go ahead and get that kicked off. And you can see it it's kicked off a workflow, and it's created the resources, and now the other things that I need to do just to make sure that this app is fully up and running is I need to specify a couple of environment variables. This is germane to just this custom UI, so I'm not going to spend a whole lot of time on these environment variables because developers would have to specify their own environment variables for their front-end UI. I won't go into a lot of detail on that. And then the last thing I'm going to do for the UI is I'm just going to expose the service as a publicly available route. So once the service is once the application is actually up and running, we'll actually be able to get to it through a URL. So if I jump back here, you can see we've already kicked off a couple of builds, and there's pods being built in OpenShift, and you can see there's already been 2 builds. That's because I updated the environment variables on there, but it actually isn't deployed yet because it is in the process of building. You can see it's still building. So we're going to give that a little bit of time to build, and while that's building, we're going to go ahead and actually deploy our Postgres cluster in the back end. And for that, like I said, we're going to be using Crunchy Data's Postgres operator for Kubernetes. And I already have that operator deployed into a different namespace in OpenShift, and that namespace is called PGO, not too creative there. So I'm just going to go ahead and switch over to that namespace. If I do a OC get pods here, you'll see I've got 2 pods deployed. Our PGO client, which you can actually deploy into Kubernetes, so you don't have to install anything locally on your machine if you don't want to. You can also install the client locally on your machine, so you can do everything locally. It's just a little bit easier for me to work directly in the Kubernetes cluster. And then we have the operator itself. We have a lot more information on how the operator works and the architecture behind the operator, both on our website as well as through blog posts and things like that. And obviously, if you're more interested in the behind-the-scenes working of the operator itself, feel free to reach out to me after the fact, and be more than happy to provide more details on that. So with that, we're going to remote into our PGO client pod, so we can actually get access to the CLI to create our cluster. And in one command, I'm going to create a high available, fully replicated Postgres cluster. And that, again, that's using our PGO client. And so here's the command. So obviously using PGO, we're telling it we want to create a cluster. We want to create it in the demo namespace. We want to name our Postgres cluster Fire App. We want to use our Crunchy Postgres GIS highly available image. So again, this is using the Crunchy container suite. And we want to have 1 read replica. So we're telling it right out of the box, we want to have 1 read replica. And with 1 read replica, that gives us a highly available database. So if anything happens to our primary database, it'll automatically fail over to our read replica. So I'll go ahead and kick that off. And you can see it created a workflow. And if I do a quick PGO show cluster, and I go into the demo namespace, and tell it I want to see all of the clusters available in that namespace, you can see it's already kicked off. And here is the pod that it's creating. And so it is in the process of creating that Postgres cluster in OpenShift. And so that's going to take a little bit, but that's not going to hold us up from doing a couple of other things that we need to do. And you can also see that it specified we want autofail in there. And a bunch of other necessary configuration items. Again, those are all germane to how the operator itself works, which I won't go into detail for the sake of time today on that.
So, you know, Adam, it's amazing. I am a developer, and how the onus of work has been taken off my shoulders if I was a developer doing this. You know, more clustering. You know, it was this one command to actually attach externally, make available your application. Just so many benefits. No more bash scripting or big scripts to deploy these things anymore.
Absolutely. Yep. Yeah. And so the next thing I need to do in my Postgres database is I do need to create a new username, and that's specifically because of how the data set that we're going to be working with in here. When we exported it from our other demo app, it pulled in a couple of other schema things. And so one of the things that that followed it was a username. So I actually need to go in and create a new username. Now, typically in Postgres, you would have to log directly into the database, create a new user, create the password, manage all that. And the problem with that in Kubernetes, if you do that in the database, now Kubernetes has no idea who that user is. It doesn't have access to the secrets. And so with this command, again, I'm telling it what cluster I want the username created in. I tell it the username, and I tell it that I want Kubernetes to manage my secrets for me. I'm not going to specify my password. I want Kubernetes to go ahead and create the secret for me, so it's available through Kube Secrets. So I do that, and it went ahead and added the new user group to the FireApp cluster, and the FireApp cluster is still being created in the background, right? So I was still able to do that, and once it's fully up and running, it's going to go ahead and be added to it. So didn't really have to wait for that. The fact that the cluster wasn't fully up and running didn't prevent me from go ahead and creating that new cluster. So now I do actually need to go in and do a couple of things directly in the database. And so if I hop back, or if I do one more PGO show cluster, here, let me just do this a little bit faster. So we'll go ahead and check on the cluster, see how it's doing. You can see that our primary database is already up and running. Our replica is not available yet. It's going to go ahead and do that in a minute. So we're going to let that keep working its process, and we're going to move on to do what I need to do in the database. So I need to switch back to the demo project space. Now we're in demo, and if I do an OC get pods, you can now see we've got some pods available, and here is our FireApp pod with the Postgres database in there. So I'm going to remote into that. So now what I need to do is I need to create a database in my Postgres cluster that I want to load in all of my data into. I could do it directly in the main Postgres database, but that is generally frowned upon. You want to create a separate database and schemas to be able to load all of your information into. So I'm going to go ahead and do that again. So now I'm moving it into just kind of normal Postgres or P-SQL commands. Give me 1 second. I need to update some of my scripts over here. So now I'm moving into just kind of normal Postgres P-SQL command line interface things. This is not using PGO or anything in Kubernetes. So now we're completely in Postgres space. So first, I'm telling it I'm exporting the password. I grabbed this from Kube Secrets, right? So once I delete the database, that password is not going to mean anything. So obviously, you would not want to be sharing your password out to the world like I am. But after this demo, this is going to be gone, so the password doesn't matter. And I'm specifying my P-SQL command on where I want to log in and create the database. And so the database I'm creating is called FireData. So go ahead and do that. And of course, since this is a, oh, whoops, sorry. That's because I'm in the wrong pod here. So let me go ahead and put it in the right pod. There we go. And so you can see I created the database in my Postgres cluster. And now after I do that, I just need to enable the Postgres extension. As I said, we created the cluster using the Crunchy Postgres GIS container. So the Postgres extension is available to us in that container. But since I created a new database, I do need to create the extension in that database as well. So here, just tell it to create the extension Postgres in that database. We've created our Postgres database. And now I have our data pre-staged into a SQL dump file because one of the least exciting things you can do in a demo is import a bunch of shape files or other spatial data. So this is just a command to import our data. And you can see in fairly short order, it's pulling that SQL dump file and loading it into the Postgres database. All right, so we're going to go ahead and let that run. Let me jump back over here. So now our main interface should be up and running. And you can see that we have an interface that looks like the one I showed you. But if I go to the different views, you don't see any green lines. You don't see any red lines. That's because our parcel data has not been provided to the map interface yet. And same thing on this view. We have no parcel information. We have none of our Santa Cruz County GIS data is available to the front-end app yet because we haven't connected the back-end database to our front-end application yet. And we're going to use PG TileServe and PG FeatureServe to do that. And you can also see we have now our primary database as well as our replica database available to us. And now we're going to go ahead and load in our 2 microservices here. So for the purposes of this demo, we're using some demo containers. We do have official Crunchy containers that if you're a paying Crunchy support subscriber, you'd have access to that. But for the purposes of this demo, we're just going to go ahead and use some development containers that are not part of our supported package. But again, happy to provide our supported containers to anybody who is a paying support subscriber. And with that, oops, before I do that, I want to make sure.
Well, just briefly, how did PG Tile and PG Server make your life easier? If you didn't have them, what would you have to do differently? Yeah, great question. And I meant to mention that up front. Right. So for anyone who's familiar with kind of a traditional geospatial stack, Postgres and Postgres are used to back many implementations, both proprietary and open source implementations. On the open source side, probably one of your most common geospatial services out there is GeoServer. And that requires a lot of configuration in the middle tier. And what PG TileServe and PG FeatureServe allow you to do is not have to focus on configuring your middle tier service layer. As I mentioned at the outset, your database is your configuration info. So once you connect your PG TileServe and PG FeatureServe to your backend database, they're essentially configured, ready to go, and your data is exposed out, ready to consume into an application. So makes it very easy to spatially enable your data in your web application. I will say it's not meant to replace those wholesale. There's a lot of things that your proprietary GIS stack and GeoServer do, and they do very well. They've been around for a long time. But these 2 new services meet a big chunk of kind of the common workflow found today in most modern spatial web applications. So if you're looking for either serving up vector tiles or web feature services, I recommend you kind of take a look at these, and I'll show you just how easy they are to deploy and expose out your data. So now we're back in our project demo space, and I'm going to go ahead and deploy our development demo containers here. And we're just going to use the OC new app workflow. And it went out and it grabbed that container, and it's creating the necessary resources. And to make sure, and the only thing that I need to do to fully configure these is I need to set 3 environment variables. 2 of those environment variables I can grab directly from secrets provided by Kubernetes. And that's going to give me my PG username and PG password. So go ahead and set that. And then the last one I need to do is I need to specify a database connection URL. And since we are using a cluster and I'm deploying PG TileServe first, PG TileServe is a read-only service in our use case. And so I don't need access to my primary database. I can actually connect it to our replica. The replica that was created by PGO is a read-only replica, so it doesn't allow me to actually change any data in that database. And you can see I'm connecting to the Fire App replica service host that's provided to me by OpenShift. So again, using the inherent features found in OpenShift and Kubernetes, and just setting them through simple command line processes. So that's all I needed to do to configure PG TileServe. And the last thing I'm going to do is I'm going to expose that service out as a publicly available route, which now it makes it available to my front-end UI. And again, in the interest of time, I went ahead and I took the service or the route that I knew we were going to be using, and I already built that into our front-end demo. So the front-end web application is already looking for this API endpoint. But real quick, if I bring this up, you can see this is what kind of we call our engineering UI. It's just meant to be a real quick check to make sure you're actually getting the data back that you think you should be getting. And you can see in our database, we have these tables available to us that are providing spatial data out. We've got the assessor parcels table, the county boundaries, facilities,
so on and so forth. The only table that we're really using in the application is this one, but all of these tables are available to us to consume in our application if we wanted to. And if I go to a preview on one of these, you can see it's providing back the boundary areas, and it's providing back the full metadata available to us in the database. And if I go to my JSON preview, you can see it provides it back as a JSON endpoint. So essentially, this is the API endpoint that we're going to be consuming in our application. I won't bring up the code in the application itself because it gets a little deep in the weeds there. But if I go back to our application, you can see this is the web map that we were looking at before. If I refresh this view and go here, now we've got our parcel boundary information available to us, and I can select it, but I'm not allowed to do anything with this data yet. And that's because, as I said, the actual update is being done through PG Feature Serve, and we haven't deployed PG Feature Serve. So you notice nothing's happening when I click on this interface, and I'm getting errors back, and that's because we don't have the PG Feature Serve API available to us. So we're going to follow very similar steps to deploy PG Feature Serve. And I will try and move through this as quickly as possible as we're running a little low on time. But essentially,
I hope everyone's following, and please do ask your questions in the player window.
Yes, please. And the other thing I'll say is I'll throw a slide up at the end here, but we do have self-serve hands-on tutorials that walk you through how to do all of this yourself. So you're free to go check those out after this talk. And they walk you through in a lot more detail than I'm going in here. And the difference.
Sorry, Adam, since you're there, a question has been asked. If you're not a developer, where can you begin to start to understand what needs to happen to build such a database? Do you need to learn Python or SQL, or what would you suggest?
So I would suggest going to our learning portal, and I'll put the link up at the end. We have a lot of great PostGIS tutorials on there on how to actually work in PostGIS, all the way up to how to add these services to your database. It goes into spatial types, how to actually different projections. We have a very robust PostGIS learning library on there. So that's where I would direct you first. Python really is once you start getting kind of up further in the stack, in terms of kind of your UI or even additional APIs, things like that. And so the one difference before I hit enter on this one, when I'm setting the database URL for PG Feature Serve, because PG Feature Serve does need to actually update the database, we are connecting it to our primary database. You can see it's using the main service host, not our replica service host. So that's the only difference there. And then I'm going to go ahead and expose that out as well to make it available to the front-end UI. So that is now exposed out. If we go back here, first let me show you kind of what PG Feature Serve looks like. So again, very similar UI. We can view the collections. We have all the same tables available to us. The only difference is these are being provided as features, not vector tiles. If you want to know what the differences are in there, we've got other videos and blog posts that we can point you to on our website. But again, all of the attribute information is being provided back there. And I see we've got 12 minutes left here, so I want to hop through this fairly quickly. And the other thing I wanted to show is, so right now there are no functions available to us, but that's going to change in just a minute here because we do need a few functions to finish out our demo here. So if I go back and I hit refresh on here, we still do not have the ability to make any updates on this, as you can see. And so the last thing I'm going to do is I'm going to go ahead and remote into my PostGIS cluster again. Oops, no, actually I don't want to remote in. I want to set up a port forward. So what this is going to let me do is this is going to let me connect to my PostGIS cluster that is running in Kubernetes, but from PG Admin, which is a database administration tool on my local desktop. So if I hop in to PG Admin and I connect to the database, going to show me all of my data here. And you can see we've got our group tables, which is where all of our information is coming from. And so the last thing I want to do is I actually want to create a couple of user-defined functions directly in the database. The one thing I'd say about the OGC API for features version 1 is it only allows gets. It does not allow put requests. So you're not actually able to update anything through that API yet. My understanding, and George can correct me if I'm wrong in this, is in the next versions of the API they're working on put. But in lieu of that, because we are working directly in PostGIS, we have the ability to create user-defined functions which can actually alter fields in the database. So the three things that this command is going to do is it's going to create a new schema. PG feature serve does require all of the functions to be in this schema, PostGIS for the web. One function is for our parcels distance search, and the other one is for our update to be able to set the fire hazard attribute from yes to no. So just by adding those two functions to the database, if I refresh, we can see that we now have, oh, sorry, helps if I actually run it in the right spot. Come on. There we go. So refresh this, and we can now see we have PostGIS for the web schema. And if I take a look at functions, we now have two functions available to us through the schema. If I go back to PG feature serve, we can now see we've got both those functions available to us through the API, again, through the standard OGC API. And hopping back here, refreshing my web interface, I can go back here, and now I have the full functionality available to me in the application. And so you can see we can update the attributes, and we can do our distance query, and it's returning back information directly from the database. And again, when I'm doing that update, it's doing the update directly into the database, so anybody else who's connected to this database is seeing the same thing. And while we still have just a couple minutes left, there's one other thing I want to be able to show. If I hop back into here, let me go ahead and remote into my container again. So I'm going to remote back into my primary PostGIS cluster, and I'm going to simulate a catastrophic database failure, which is always fun, right? Everybody always wants to crash their database on purpose. So I'm going to go ahead and delete my PG data file. That's where all the information about the data is contained. As I said, it's a high availability cluster. So it says permission was denied, but if I wait a little bit here, we're actually going to see that this we're going to lose the connection here. You can see connection refused. Well, what happened is if I go back into my PGO container, and I show the clusters, so if I can type properly, you can see I've already reestablished my my cluster up there, and it happened even too fast for me. But you can see this was our primary cluster before, and that is the one that I intentionally crashed. So it automatically failed over to the replica, and so this is actually our primary cluster now. You can see it's designated as primary. So you would think that might actually mess up our application, but because we're using the service host provided to us by OpenShift and Kubernetes, if I go back over to my demo and I hit refresh to make sure everything is working properly, you can see we still have the same data that was there before, and I can go and I can select a new one, I can update that, and I still have all the same functionality. So that quickly, your database can fail, and the PGO, the Crunchy PGO in combination with Crunchy Container Suite will automatically fail over, bring down your primary database, replace it with a replica, and restore your primary as a replica, and do it completely seamless without you having to do any special work or any Herculean effort. So with that, I'm going to go ahead and bring my closing slide up. So here are the links that I told you that would show. So if you want to learn more, please go to our developer portal where you can get access to our developer containers, our learning portal, our GitHub repo, and if you want to reach out to me directly, if you have any other follow-on questions, that's how you can get a hold of me. With that, Michelle, I will hand it back to you.
Oh, well, thank you, Adam. That was wonderful. And this you can add to the list of tutorials, because this is a great lesson tutorial you just gave us on interactively creating geospatial application. Do have a question from the audience, and we could probably bring George back in. We've got 4 minutes left. And the question from the audience is, well, how would you protect, secure, and rate limit the API endpoints? I'm going to pass this to whoever wants to take it. I have an answer, but I'll see. Adam, you want to take that one? How would you?
Go ahead and take that one. Yeah, that's a great question. We get it all the time. So sort of mentioned up front, so we did not integrate any authentication or any caching into either of these services. There's architectural ways that you can do that. Probably the most common way would be route it through an API gateway that allows you to do that type of rate limiting upfront on that, as well as caching strategies, integration with your enterprise authentication mechanism. But that'd be the short answer from my perspective on how you would do that.
Maybe I chip in a little bit, Michelle, on that
Absolutely.
as well, and pull out something that Adam hit on as he was going through there, and that is the lightweightness of these APIs with respect to, you know, PostGIS as a database provides all of that horsepower and information and knowledge. You put a little lightweight API on that. Industry practice allows you to deploy it in the cloud using Redshift and other, you know, industry practices for rate limiting and traffic management and the like. You know, what we're seeing is the ability to bring geospatial data into industry practice in a way that we've never done before.
Mm-hmm. And I will also add that we like separation of concerns. So with rate limiting and putting policies around your APIs is of importance. I echo again what Adam said, put a API manager in front of it. Red Hat has 3Scale, which is the number leader in that space. And you can do chargebacks, rate limiting, policy setting, security where there was no security before, just things like that. But yeah, separate the concerns and actually just go ahead and put some kind of rate limiter or so in front of it. Guys, this was a fascinating hour. Time flies when you're having fun. Just want to thank you all for coming. I'm looking to see if there's any other questions that can be had. George, one for you. People like what they hear and heard about OGC. How can they get involved?
Yeah, ogc.org. So go there, look for the APIs, you know, that Adam just showed. He mentioned that it's a continuing evolving. We're adding the ability to update, you know, CRUD functions on top of Access are what's coming forward in the API for features. We want your input to make your geospatial data more readily available so that PostGIS can serve it up better, so that Red Hat and OpenShift and 3Scale, all of those techniques working together is what we need to serve the customers that we all support.
Great. And Adam, we love it when a plan comes together. The demo guide stayed away. You got Postgres, PostGIS, Kubernetes, open geospatial APIs. You got all that working together interactively live in front of the studio audience. So thank you for that. Again, we will put that information that you put up about how to get more information and make sure that all our audience has it. And we thank you all for coming, and stay tuned for the next DevNation. It's August 18th. It's data science at the edge. We're following this data pattern here. So please stay tuned Tuesdays at 4 p.m. Thank you all for joining.